The next chapter, moving charges and magnetism. Now you know the charges in motion produces magnetic field, in the sense the current. The current flowing through a conductor produces magnetic field. Actually in 1819, a scientist by name Oersted showed that when current flows through a conductor, the pieces of magnet below the conductor shows the force experienced. That means that there should produce a magnetic field due to the current in motion. From this, he concluded that current flowing through a conductor produces magnetic field. Now you know current is due to charges in motion. Therefore, this is nothing but moving charges. These moving charges produces magnetic field. That is what we call it as moving charges and magnetism. In this we are going to discuss different aspects of this magnetism, about the charges, current flowing through a circular coil, everything we discuss. Now in that one we take the first topic. The first topic is force experienced by the charge moving in a magnetic field. Force experienced by the charge moving in a magnetic field. Now for example, you consider a magnetic field, a uniform magnetic field. A uniform magnetic field is one whose strength is same at all the points. Let B is the strength of the magnetic field. Let here is a charge Q moves in the magnetic field with velocity v by making an angle theta. Then this is going to be v cos theta and this is v sin theta. Because velocity is a vector which can be resolved into two components. Then the component of velocity perpendicular to B is one which is v cos theta. Then this charge Q moving in the magnetic field experiences the force. Therefore, the charge moving in a magnetic field experiences the force. The force experienced by the charge moving in a magnetic field is given by F, and it is, try to understand, consider a uniform magnetic field of strength B. Let this is the direction of B. There is a charge Q moving in the magnetic field by making an angle theta. V, velocity is a vector quantity, B is a vector quantity, it makes an angle theta. Then V can be resolved into V cos theta and V sin theta, where V sin theta is the component of velocity which is perpendicular to B. Then charge will experience the force. Then the force experienced is given by force is, first one, directly proportional to the magnitude of the charge Q, directly proportional to the magnitude of the charge Q. Second one, directly proportional to the strength of the magnetic field. B. Three. Directly proportional to the velocity of the charge V. Fourth, directly proportional to the angle between the sine of the angle between the direction of the magnetic field and the direction of the magnetic field and the velocity vector, that is sin theta. Therefore, the force experienced by the charge moving in the magnetic field is directly proportional to the magnitude of the charge Q, directly proportional to the strength of the magnetic field B, directly proportional to the velocity of the charge, directly proportional to the sine of the angle between the direction of the magnetic field and the velocity vector, that is F proportional to first one Q, F proportional to second one B, F proportional to third one V, F proportional to sin theta, or F proportional to Q B V sin theta. Therefore,